67, 6.
I think it's the same.
Is it the same?
Yeah, it's the same. You see? It's the same. Exactly the same. Yeah, it's the same. Okay,
So the second question?
yeah, so for the regression results, you first check the model. The model is significant, okay? And then you check the R-square, okay, how much percentage is the model predicting the dependent variable, and then you check the coefficient, which variables are significant, okay? So this is the most important values to check in regression model. Then the question is asking whether if in this case you have I will delete this. Okay, if someone's parents is 70 years old and their grandmother is 80 and the grandfather is 75, we want to know how long can he live. Okay, so to predict that, we go to the same procedure. Okay, regression, linear, and save, and check the mean and individual. Same. Okay,
Also
same
the
step as
unstandard-
before. Yes.
We didn't check the unstandardized.
In this question, it's not asking me to check the regression diagnostics, so I don't need to check. Yeah, this question only asks me to predict the.
And you said diagnostics will not be included, right?
Yeah, unless it's specified. Otherwise, by default, no need.
No, you said that the exam will not have any diagnostics, right?
Yes.
Okay.
Yes.
So we're not gonna have to use that.
Okay, so click on continue. And okay, you will got the range of the
68.
yeah 60 and the 674. Okay, yeah, so use this range is more accurate. And in this question, it's asking about the mean longevity, and the next question is asking about the mean longevity. So you definitely need to use this one. Okay. Yes. Okay, so that's the second question. We have two more to go. Question 3 is P723. I think this one is to check the Derby-Watson's test. 723. Okay. Yeah. Okay. This question is talking about the relationship between snowfall and the selling of the sales of the snow tires. Okay, so the data was collected over the winter months. The data was collected weekly about the weekly sales and the weekly snowfall. Okay, and so the dependent variable here is the sales of the tire. The independent variable is the snowfall. Okay, and we want to do the regression.
It's not this data. You must open,
Yeah, I need to open the data set.
Dr. Again, which one is dependent and what's independent?
Dependent variable is the sales of the tire.
Dependent.
Dependent, yeah.
Yes.
Independent is the snowfall.
Yes.
Okay. And so let's open the data. Okay, so you can see I have the first two variables, tires. Okay, it's the dependent variable, the sales of the tire. The second variable is a snowfall. And the question is asking the first one, develop a regression model and use a software package to produce the statistics. So I will just make the regression model. I click on the linear and put the tires into dependent and the snowfall as independent. And check. And you can see the result. The model is significant. It only predicts 38% of the variance. Then the snowfall is significant predictor. Okay, so the next question asks perform a complete diagnostics analysis to determine whether the required conditions are satisfied. So to do the regression diagnostics, there are 3 conditions we have to do. First is the residue should be randomly distributed. To do that, we need to create the residues for the data set. So we go to Analyze and Regression, and then click on the Linear, and then click on the Save. In this case, we need to check the residues, unstandardized and standardized. Predict values, we also need to check unstandardized and standardized. The purpose of the predicted values is we want to check the constant distribution of the residues, okay, which is we plot the residues against the predicted values. Okay, so to do that, we need to have both data in the data set. So click on OK, and the program will automatically shows you the unstandardized predicted values, unstandardized residue, standardized predicted value, and standardized residue. Okay, so let's first do the normality test for the residue. We go to Analyze and the Descriptive Statistics and choose Explore. And we put unstandardized residue into the dependent list, and then we click on the plot, deselect them, and yeah, we only check the histogram and the normality tests. Click on OK, and let's see. Okay, so yeah, the Shapiro-Wilk test shows that it's more than 0.05, which means it's normally distributed. And when we check the graph here, the histogram here, it is normally distributed. So the first required condition is met. Okay. The second required condition is to check the constant distribution of the residues, which is to check the graph of the scatter plot, and for the x-axis, it should be the predicted unstandardized predicted value, and the y-axis should be the unstandardized residue. And we want to see the pattern if they have some relationship or it's randomly distributed. If it's randomly distributed, it means that the residue and the predicted value has no relationship, but they are constantly distributed. And in that case, the second required condition is also met.
This one, I thought it's heteroscedasticity.
Yeah, it is. It's
Oh,
like this.
Heteroscedasticity.
Yeah, because it's
It's just like this.
Yeah.
Yes, it's a heteroscedasticity.
That one.
And what is the second one? Second one is the variance.
This is the test of constant variance. This is
Yes,
what I mean,
constant
right?
variance, and this,
So here it's not constant variance because it's heteroscedastic.
okay, so error variable must have a constant variance, and the errors must be independent of each other. Oh, okay.
This is the toilet.
What time is it? Oh my goodness, it's
So I think you have to invite me today.
Yes.
So all the time.
يقول خاصة أنا بسجل قاعد يصير أبلود لليوتيوب.
Yes, yeah, the heteroscedasticity is about the constant variance, right? Yes.
Yeah. But,
So what does
should
it
we
mean?
say
What
it's constant or not constant?
It's not constant.
It's not
There's no pattern. If you see it's a linear relationship, then there's some relationship. If it's randomly scattered, that means it's homoscedasticity.
But this one is not randomly
I
scattered.
finally got it correct.
Do you think this one is randomly scattered?
Yes. Where is it?
Because I don't see it as randomly scattered. I can
So
see that
what is a pattern? Can you?
Yeah, we can see it's
it's
like
expanding. Like there's the going to the next.
Like a funnel.
You see
yeah, yeah,
this.
yeah,
Yeah.
yeah.
Okay. That's true. But this is an outlier.
No, this is the starting point. I imagine this is the starting point.
This could be an outlier. I don't know. Anyway, this is very subjective. Okay, and we will assume the second requirement condition is met. Okay, and then for the third condition, which is the multicollinearity or the first order autocorrelation, we can use the Durbin-Watson's test. Okay, the name sounds scary, but the test is very easy. Okay, we just go to the same regression test. Yes. Okay, so we go to analyze and the regression and the linear, and then in the statistics we check Durbin-Watson's test. Okay, and then click on OK. It will give us the value of D. Okay, so this value is a D value. Okay, for the Durbin-Watson's test, it gives us the D value. For the D value, we need to check the DU and the DW. Remember?
DL. DU and DL.
DU and DL.
Because the D is the DW. Some people say the D, some people say the DW. What's this about?
Hold on. Okay. Yeah, it's dr and du. It's dr and du. Mohammed. Wait. Okay, so remember the value of d is 1.00 something, right? So at the when alpha is 0.05, the d value, the dr value is okay. When alpha equals 0.05, the dr is equals 1.1 and du equals 1.54. We can get this value from the d-test table at the end of the book. Okay. Anyway, you don't need to have that table, but you need to have in mind at alpha equals 0.05 significance, dr and du is this value. And what you need to do is you compare this d value with the scale here. Okay, so now the d value is 1.00 something.
6.
It's smaller than dr, right?
Yeah.
Yeah, so there exists the first order autocorrelation. Okay, so you can conclude that this model has the autocorrelation problem. Okay, so in that case, we need to consider the time series variable in this model. That's why we add one more variable into. Mohammed, you missed the most important part.
Really? I'm sorry, one is calling me.
Anyway, it's okay.
Maybe you could do me a favor.
I think you should consider taking out this from the test.
Where is the thing? Okay, this one. Okay, so that's why we. Okay, so Mohammed, what we did is we did the Durbin-Watson's test, okay, which is one of the regression diagnostics. Okay, you were here when we talk about the first two requirements, right? The first required conditions, the normality test of the residue, and also a heteroscedasticity. Okay, these are the first two required conditions. The third required condition is multicollinearity or the autocorrelation between the variables. Okay, the first order autocorrelation means that there is some time serial variables missing in the data set. To check that, we use Durbin-Watson's test, and you can find the Durbin-Watson's test in the regression model. If you go to analyze and the regression and the linear, and check statistics, you can check Durbin-Watson's test. Okay, if you check that, because I already did that. Okay, and it will give you the value of D here in the Durbin-Watson's test, which is in the model summary table, the last column. Okay, this is something new. Okay, something added to this table. And given that D value, we can check in the this scale, okay? If D, because DL at the significance level of 0.05, DL equals 1.10, okay? Okay, if D is smaller than DL, then from this scale we can conclude there exists Durbin-Watson's effect times the autocorrelation problem. So we need to add one more variable in the data set, which is a time serial variable. In this case, because the data was collected over different weeks, so we added the week variable into this model. So we added one more variable, week. Yes?
Does it make
What?
no, just doesn't make a difference if I add a year because I add a year.
You
It's the same
added.
answer, but just year instead of week.
I added the week variable and I put the added the week variable, and we can run the model again to see if there's any improvement of the model. Okay, so this time we put a week in the independent variable, and we check again. We check the Durbin-Watson's test. Okay, you can see the model actually has been improved a lot. Before the model is significant, but it only explained 38% of the variance. The next model, when I add the week variable, the model is more significant, and it explained about 70% of the variance, which means the majority of the variance has been explained by using these two variables.
So sorry, what is the variable you added?
Week.
Week, okay.
Yeah, because the data was collected over 20 something
22.
weeks.
22
Yeah,
weeks.
22 weeks, yes. Yeah,
Okay.
that's true. Very good.
What if the Durbin-Watson was between DU and DL?
Okay, you have to check this one, the scale here. Okay, so if it's smaller than DL, if the D value is smaller than DL, DL is about 1.10,
Yeah.
okay? If it's smaller than DL, that means there exists autocorrelation.
Yeah.
Okay, then we need to add the time variable. And if it falls between DL and DU, it's inconclusive. We're not sure whether it exists or not. If it's 4 between DU and the 4 minus DU, then it doesn't exist. So the data is fine.
Okay.
And again, between 4 minus DU and 4 minus DL, it's inconclusive. If it's more than 4 minus DL, then it exists. Okay, so this scale is important.
This is from the slides?
This is from the slides. It's from the slides of which one? 72, Durbin-Watson test.
Okay.
Okay. Anyway, it's open book. Okay, you can always check the slides.
But the diagnostics is not included in the test.
Yes, I think so.
Can we open and check, please? I'm trying everything.
No, like
Give us links.
You have already made the questions, right?
Yes, yes.
Hmm.
Okay, so we're almost done. What's next? Okay, yeah. Yes, I think we finished. Oh my goodness. Last one. Last question. Okay, last question is page 761. It's actually the hardest one. You will not have this kind of question in the final exam. Okay, actually, so before you do the regression, as I said, you need to first check the scatter diagrams for dependent variable and each of the independent variables.
Question 4, right?
This is the last question, yes. And then when I check those diagrams, I find that the pH, so the question, the whole idea is that the chlorine depletion in the pool will be affected by the weather, by the pH level, and by the time. Okay, those three predictors for this regression model. And when I put the independent variable into each scatter diagrams for the dependent variable, I find that the pH level has a very interesting curve. It's not a linear relationship, okay? It's a parabola, okay? It's a curve, which means it's not a first order model. It's polynomial model, okay? So in that case, pH value should have a squared value in the model. So I pre-calculated this squared value for pH value in SPSS, no, in Excel, and then I transformed into SPSS data. So I need to open the data set. This is the last question. Okay, so in the data set, I have a dependent variable, which is the percentage of the depletion of the chlorine in the pool, then temperature of the pool, pH level, weather, and okay. So for the weather variable here, it's a nominal variable. So we need to recode this weather variable into two dummy variables because it has three categories. Right? Remember how to change the nominal variable into dummy variables in the regression model. So we recoded the weather variable into two dummy variables. To do the recoding, you'll go to transform and recode it into different variables. Then we need to give the value for each of the variables. Okay, so we can name it as, for example, weather1, W1, as a new variable, and you change the old and new value. Old value 1 and new value is also 1. And then all the other variables should be 0. Okay.
You should have added it, right?
Yes, but I already did that, so I just want to show you how to do it. So you added that, and then, okay, so it should be 1 for 1. And then all others should be 0. Okay? Yeah, same for the other variable. And then you need to give the values here for the W1 variable. One is for the mainly cloudy, and the other is for others. And the second variable, because there are three categories: mainly cloudy, sunny, and partly sunny. So you need to recode each category for the.
This is similar to the final.
This is not included. It's,
Yes, yeah, there will be similar questions like that. Okay, to recode a nominal variable into a dummy variable and then put it in the regression model. Okay, yes. Okay, so you need to know the steps how to do it. Recode the.
So, sorry.
Yes.
You added only week 1 and week 2, or what?
Week 1, because there are only 3 categories. Remember, it's n minus 1 categories for the dummy variables. If there are 3 categories, we only need 2 dummy variables. If there is 4 categories, we only need 3 dummy variables, because the last one is already included in these 2. Remember in the matrix?
So you do the same for week 1 and week 2?
Yes, week 1 and 2, but you have to be careful of the values here. Okay, the values should be different correspondingly. And once you finish those recoding, you should always go to analyze and the frequencies and check if the new variables are correct or not. So I put these 3 variables in and double check. Okay, you can see this is the original weather variable, and each category has 33%. And then the new variables, okay, for the mainly cloudy, 33%. And for the sunny, also 33%. The rest are the last category. Okay, so each category is 33%, which means the recoding process is correct, no problem. So once you finish that, remember we said that it's a polynomial model, so we put the pH square in the model as well. And then we assume that temperature and the pH value will have some interaction in the model. So we add this interaction into the model as well, and then we can check if this interaction is effective, is predictive or not. So now we can run the regression model and click on the linear. We put the percentage of depletion of the chlorine into the dependent variable, and the rest of the variables all into the independent variable, except weather, because we have 2 dummy variables for the weather. And then,
So we decoded weather only?
we decoded a bit because weather is the only nominal variable in the dependent variable. So we need to decode the weather into 2 dummy variables. And we only put these 2 dummy variables into the equation. We don't need to put the original weather variable into the equation. Okay? And then
In order to convert it into interval.
it's dummy variable. It's kind of interval.
Okay.
Yeah, we can explain it in equation. Okay, so click on the OK, and then you will first see the ANOVA test for the model validity. So the significant p-value is significant. Okay, it's smaller than 0.05. So the model is valid, and the R square is 0.65. Which means it explains 65% of the variance of the dependent variable. And now let's check the coefficients of the predictors. Temperature is not significant. Temperature is not significant. And pH level is significant. Weather mainly cloudy is not significant. Sunny is not significant. And pH square is significant. Temperature and pH level interaction is not significant. So let's exclude the interaction and see, because the interaction is not significant, and we want to remove the interaction to see if the model will change or not. So go to again linear. This time we kick out the interaction between temperature and the pH value. And let's see. Okay, so R square is not changed. Okay, same. And the model is valid. And okay, so yeah, all other variables are, temperature becomes significant. So in that case, we should exclude the interaction. Okay, because adding the interaction doesn't improve the model, and it will affect the impact from temperature variable. So now this is the final equation we have for this regression model. We will have temperature, which has some positive impact on the dependent variable, and the coefficient is 0.194. pH level, it's also a significant predictor. The mainly cloudy, the weather mainly cloudy is not a predictor. Sunny is a predictor. If it is sunny, okay, then it will the percentage of depletion will increase, and if it's not sunny, then it will not increase. Okay, then the pH value square is also a significant predictor.
The sun is not significant.
Sunny is it's not, sorry, it's not. I got wrong. So it's not significant. Weather is not significant. Okay, all others are significant.
Doctor, why you don't put weather with interaction with temperature and
Because this is dummy variable, so we cannot do the interaction with dummy variable. Okay. Okay, so that's the final model. What else? What are other questions? So write the equation to of the model that you would suggest. Use the regression analysis to estimate the model's coefficients. We did that. Test to determine whether the model is valid. We also did that. Can we infer that higher temperatures deplete chlorine more quickly? So, what's your conclusion? Yes, right? The more the temperature and the more depletion of the chlorine. Is there evidence to infer that belief about the relationship between chlorine depletion and the pH level is correct? It is correct because it's significant. Can we infer that weather is a factor in chlorine depletion? No, it's not. Okay, so that's it. So we can answer all the questions from this analysis. Okay, so that's all for week 5 assignment. What time is it? Okay,
Are you sure you're including one question of this?
No, we will not have this question.
Okay.
Thank you so much.
You need to know how to do dummy, but we will not have a second order regression model. Okay, second. Okay, non-parametric.
So non-parametric is not there in the diagnostics?
It is there, it is there, okay? So, for example,
Is there?
let's use
But doctor, the questions will be similar to the ones in the book, right?
yes.
So we can answer the question from the book.
Yes.
That will help, right?
Yes, just check your assignment and make sure you can do those assignments.
I mean, the
But,
questions are from the book.
But doctor, we don't have any assignment about non-parametric.
Yes, I'm showing you now. Okay, I will give you one exercise now.
ما خلت شيء مصور ولا بعرف يوم بشوف الفيديو ولا بعرف هذا منشور بس
Okay, for example, in the GSS data, we have the happy variable, which is about the how do you feel about the life, like happiness of life. I will give you the measurement. The measurement is like the first is very happy, second is medium, and the last is not happy. So you can tell the scale is ordinal, right? Yeah. And then, for example, I want to compare different races has different feelings of happiness of life. What kind of non-parametric?
The last question is essay, right? There is no data.
No, we have 4 questions, okay? 4 questions. This is the 4th question. We have 5 questions. This is the 4th question.
This is when we have ordinal data.
Yeah, ordinal dependent variable, and then categorical nominal independent variable. So to do this,
Independent variable would be nominal.
independent variable is nominal and the dependent variable is ordinal. What kind of statistics? You don't need to, because identifying different types of their measurement will help you to decide which statistics to use. Okay, so remember I will show you the non-parametric statistics slide.
There's so many different types.
Yes, this is the most important slide for non-parametric statistics. Okay, so if you, there are three groups now, right? White, black, and other, right? So three groups, definitely you should go for here, okay? Either Kruskal-Wallis test or Friedman test. Friedman test is like blocks. Did I mention any blocks? No, so go for Kruskal-Wallis test. Okay, simple, right? Yeah, so identify how many groups.
Yeah.
Okay, if it's 2, check one of those. If it's 3, okay, check 2 of these. And if check whether it's blocks or not blocks. If there's not mentioning any blocks, then go for Kruskal-Wallis test. And you can find in the analyze and go to parametric test and the legal dialogues and check the K independent samples.
This is for which one?
This is to check different races has different feelings of happiness.
3 or more groups. So this is the Kruskal-Wallis.
Yes.
I
Yeah.
think the black is the most happiest.
We can check.
Normally they are very happy.
Yes, we can check whether you're right or not.
Zero
Grouping
grade,
variable. Okay, grouping variable. Okay, so here because we have 3 groups, you need to define the range from 1 to 3. Okay, minimum to maximum 1 to 3, and then let's find the happy variable. Happy variable is here. Okay, and click on OK. Yes, it's significant. Okay, be careful whether it's 2 tail or 1 tail. Okay, so
It's 2 tail divided by 2.
yes, we can. Let's double check. Okay, so Kruskal-Wallis test. I think it's 2 tail. It's 2 tail, yes, because it's now hypothesis. There's no difference. Okay, it's 2 tail. So you don't need to divide by 2. Just to use this significance value. So it's already smaller than 0.05. So it's significant. There are differences, and you can see which one has the highest score. 2. 2 is what?
Black.
Are you sure? White, yes, you're right. White, black, and other. Yes, you're right.
I told you. Bonus.
That's cute.
I can answer just like this.
By
I don't need to run
intuition.
regression.
We have a
From
regression.
experience.
Okay, so yeah, that kind of example. And okay, so
As poor as you are, as
Okay.
here.
and okay, other non-parametric tests. If there are 2 groups, okay, if it's matched pair, you use sign test. If it's the dependent variable is non-normally distributed intervariable, you use Wilson sign
This
test.
is too much confusing. Well, it's too much.
Yes.
Too
Because we
good.
didn't have any practice on these ones. It's hard.
It's really.
But it's open book, right?
So we concentrate.
In the book, there is non-parametric in the book.
What?
Parametric. There's non-parametric
Non-parametric.
in the book.
Yes, yes, yes.
So we concentrate on 3 groups.
For example, 2 groups, we can do an exercise, male and a female, okay? And then we compare the happiness in the marriage, okay?
Even 2 groups, there's 2 types.
Yes.
Other than matched.
Okay, so we go to 2 independent sample test, and because this is what? This is let's check. Okay, 2 groups. It's independent, so we use the Wilson rank sum test. Okay, it's not matched pair, it's not interval variable. The dependent variable is the happiness of marriage, 3 scales, ordinal variable. Okay, and so let's do it. The grouping variable is sex, defined define groups 1 and 2 like in independent sum t-test, and let's find the happiness of marriage variable here. Okay.
شو السؤال هنا؟
And what's your guess?
Let me predict. What's the question?
Happiness of marriage.
Male and female.
Happiness
Who
of
feels
marriage.
happier in
This
the
is kind of
marriage?
answer.
صور بعد الدور.
This is a political
I
question.
think both of them are not happy. Not significant.
Okay, maybe your guess is right. Yeah, it's not significant.
Please come with me to the exam, please, Hamlet.
This is a politically right.
Here's an oracle.
Okay. Yeah, you see, female has a slightly higher score than male, but it's not significant. Okay. Yeah.
So-
Okay, anyway, so that's it.
Thank you so much.
You're welcome. Okay. Yeah. Thank you. You're welcome. The beauty of statistics, don't say that in the work nobody cares about p-values, okay? Because earlier you are all dealing with descriptive statistics. If you say that male and females feel happier in marriage than males from descriptive statistics, that's not true. Okay, because it's all dependent on the small samples. If you want to predict the population, you have to use a p-value. Okay, so p-value gives you the power to say whether this is politically correct or not. Okay, so that is the power of inferential statistics. It is very useful. And what else? Lastly, okay, and I want to say thank you to you all. I really enjoyed teaching this class. Actually, you are the best students I have ever taught. Really, yeah, for the past 6 and more years, you are the best. Yes, you are the best students ever. And okay, if you need any help in the future, here are my contact information, and also I'm available on all these social media channels.
WeChat.
WeChat.
After
What's
this
up?
class,
Yeah.
everyone is downloading this app.
Yeah, Instagram and Facebook. I have Twitter and others, but then these are the 4 most used
It
social
depends if
media.
you have a lot of followers.